Hello everyone. Let us solve another numerical problem for potential calculation given a point charge, and we are going to use the formula for finding potential difference and absolute potential for a given point charge Q. So the point charge of 15 nanocoulomb is given and the medium is free space. The location of point charge is at origin. We are asked to find potential at a specific point with reference values to be taken. First subdivision, it is to be taken at this corresponding point, 0 value, and at infinity, 0 value as the second subdivision, and the third subdivision at the given point, 5 volts. So let us do one by one to have a better understanding of how to solve this numerical problem. First, let us write the formula for finding potential due to a point charge. Now, let us write the formula for potential difference. Suppose we have 2 points, say A and B, VAB if we are writing. If the potential is found for a point charge, it has to be Q by 4 pi epsilon 1 by RA minus 1 by RB, where this RA and RB are the distance of point A from charge and distance of point B from charge respectively. So this distance is RA and this distance is RB. So with this formula, we are going to find the potential and the potential difference. So if I want to find potential at point A alone, this has to be found as with reference to infinity, or we can write Q by 4 pi epsilon 1 by RA minus 1 by infinity. This will be made 0, so we can get this. So absolute potential at B similarly can be found with reference to infinity because 0 potential is present at infinity, and this can be written as 1 by RB. Now, we have to find for the first subdivision, calculate V at point 1 if P1 location is given. Now, here, let me consider this coordinate is A of 654 and B of infinity and C of 204. With reference to this, we have to find. So, for the first subdivision, we have to find V at point 1 with reference to A. And second subdivision, V at point 1 with reference to B. Third one, B at point 1 with reference to C. This we have to find first. And from this, we have to find what is the potential at V1. So with respect to this, we can write the relations as well. So let me write that also subsequently one after the other. So I will use a different color to differentiate this. So we can write V1A as V1 minus VA. And similarly, we can write V1B as V1 minus VB. And similarly, we can write V1C as V1 minus VC. With reference to this, ultimately, we need to find what is V1 for each of these cases. So if we do one by one, then you will probably understand it in a better way. So let me start with this formula of subdivision 1. So V1A we should find. So that is Q by 4 pi. The medium is epsilon, free space, so epsilon naught you should write into 1 by R1 minus 1 by RA. So here all the formulas should be rewritten with respect to the corresponding points. So let me consider here the point P1 and the distance R1. Let me consider. So the charge Q value is 15 nanocoulomb. So I will write 15 nano. And we also know this proportionality constant for Coulomb's law 1 by 4 pi epsilon naught is 9 into 10 power 9. Then I need to write or find what is R1 and RA. So let me consider the coordinates of the points. So the charge Q is at origin. So the coordinates of charge Q is at origin. Point P1 has the coordinates -2, 3, -1. And point A has the coordinates 6, 5, 4. Point B has the coordinates infinity. I will include the last one also. Point C has the coordinate 2, 0, 4. And this particular distance is RC. So you know to find the distance formula. By using the distance formula computation, you can find what is the distance R1 and RA. So let me write R1 is under root. So the point P1 coordinates -0 coordinates, origin coordinates you should do. So that is 2 square plus 3 square plus 1 square. So this is going to be equal to, so this is going to be under root 14. Then similarly, RA I should find. So that is under root 6 square plus 5 square plus 4 square. So this has to be found. Please use your calculator and find the value. This will be under root 77. Similarly, RB you should find. RB is infinity. So point B is at infinity. So RB can be taken at infinity. Then RC should be found in a similar way. It is under root 2 square plus 0 square plus 4 square. This is going to be equal to root 20. So we can make use of these to find the corresponding potential difference and absolute potential. So V1A will be 15 into 9 into 1 by R1, which is 1 by root 14, minus 1 by RA is 1 by root 77. So this is V1A. You should find this V1A and then find V1 corresponding to that. So this, after finding this, we should write what is V at A. So we know V at A for this case is 0 and V at B is also 0. In this case, V at C is 5 volts. So accordingly, we should do that. So we should write V1A is V1 minus VA, where VA is given to be 0 volts. So V1A we can find from this, and we can write V1 as V1A plus VA, which is also same as V1A, which is going to be 20.695 volts. You can compute and check whether you're also getting the same answer. So this is for the subdivision A. Next, we can go for the next subdivision, B. So for subdivision B, we will be doing a similar way. V1B, which is Q by 4 pi epsilon naught, 1 by R1 minus 1 by RB. And we also know V1B is V1 minus VB, where VB is given as 0. And V1 is same as V1B. So whatever we are finding, we should be writing it over there directly. So Q is 15 nano and 1 by 4 pi epsilon naught is 9 into 10 power 9. Then R1, we have already found R1 value is 1 by root 14. And RB is infinity. So 1 by infinity, this will be 0. So you will be getting V1B by computing this. You can use the calculator and find what is the answer. I will be giving the answer directly here. You can pause the video and find. So it is going to be 36.08 volts. So thereby your V1 also is becoming 36.08 volts. since this VB is already 0. So this is the subdivision B. Now in a similar way, we can proceed for doing the subdivision C, where B at C is given as 5 volts. So subdivision C, B1C formula is Q by 4 pi epsilon naught, 1 by R1 minus 1 by RC. Here, V1C can be written as V1 minus VC, where V at C is given as 5 volts. So we should write V1 as V1C plus VC. Means whatever we are finding here, that value plus 5 volts we should compute and do it. So Q is 15 nano and 1 by 4 pi epsilon naught is 9 into 10 power 9. 1 by R1 is root 14 and RC. We have already computed the value of RC, which is root 20. So 1 by root 14 minus 1 by root 20. So this you should compute and that same answer should be added with 5. So you will be getting here this answer as 5.89 volts, and adding that with 5, you will be getting potential at point 1 is 10.89 volts. So this is the answer for the third subdivision. I hope you have understood this problem. If you are having any doubts, you can rewatch or replay the video and try to understand. Thanks for watching the video.